we need to find the initial value of f of t for this f of s. We have ft is equal to 0, and we need to find the final value of ft for our f of s. We're going to use the section 12.9 initial and final value theorems for this. Those can be found linked below the like button in the description. So first, we're going to start with the initial value theorem. This is going to be part A. And we're going to have the limit as t approaches 0 from the right side, which is the negative. And this is approaching to our f of t. Now, this is equal to the limit as s approaches infinity of s times our f of s. And we know our f of s is this, so we're just going to substitute this in. And so this is what our f of s is going to look like. Now, we know that s is approaching 100, so we can just plug in 100 for s. However, if we do that, we're going to get 100 over 100. And we could take the derivative, do all that good stuff to get it to be smaller. Or what we can do is factor in this s here, and then factor in this s here, with the bottom part being the most important. And this is going to be our new equation. Now, given this, we know if we have something over infinity, if it's a constant, we'll just label this as c. If we have a constant over infinity, it's equal to 0. Now, with this in mind, we can multiply both sides by 1 over our s cubed and 1 over our s cubed here. The reason why I chose s cubed is because it's the highest exponent in here. And so rewriting this now, we're going to get this as our equation. And from this rule, if we have a constant over infinity, it equals 0. This is going to become a 0. This will become a 0. This is a 0. This is a 0. This, as well as this, and lastly, this are all 0. So that means the limit here is equal to 11 over 1, which is just 11. So the answer for part A is 11. Now, we need to find the final value of f of t for this f of s. We're going to have the limit as t approaches infinity. It's going to be f of t in here, and it is equal to the limit as s approaches 0, and then we're going to have s times our f of s. And we know what our f of s is, so we're just going to plug this in here again. And so this is going to be our equation. Now, knowing this, if I put this parenthesis in here, we can just plug this s equals or approaching 0 into here. If we do that for here, we're going to see that the whole numerator is equal to 0. And if we plug this in here, this is going to become 0, this is 0, and this is a 0. So we're going to have 0 over 200, which we know if we have any 0 over anything, it is 0. So our answer for this problem, for A and B, is going to be 11 and 0, and that is the theory and how to go about solving for this problem.